Section 4. Transparency and Explainability in AI Learning Objectives. By the end of this section, learners will be able to 1. Define transparency and explainability in the context of AI. 2. Understand why many AI systems are called black boxes. 3. Identify risks when decisions are made by systems that cannot be explained. 4. Explore approaches to improving transparency, including explainable AI, human-in-the-loop models, and policy frameworks. We've now seen why fairness matters and how bias threatens it. Next, let's explore another critical pillar: transparency and explainability in AI. Imagine this. You're denied a loan, or an AI system says you can't take a certain exam, or even recommends a life-changing medical treatment. You ask, why was this decision made? And the answer is, we don't really know. The system just said so. That's the problem we face today. Many AI systems are like black boxes. What do we mean by black box? A black box model is one where we can see the inputs, what data went in, and the outputs, the decision that came out. But we can't easily explain the reasoning process in between. Deep learning models, for example, have millions of parameters. They can make extremely accurate decisions, but even the engineers who built them sometimes struggle to explain exactly why a particular decision was made. Why lack of transparency is dangerous. When AI decisions affect real people, lack of transparency creates risks. No accountability. If a system denies you a loan, who can you appeal to? No trust. People lose confidence in systems they don't understand. No correction. Bias or errors can go undetected if the reasoning isn't clear. Imagine a medical AI that recommends a treatment, but no one can explain why. Would you trust it with your life? Transparency versus explainability. These two terms are often used together but mean slightly different things. Transparency equals how much information about the model is open to review, e.g., what training data was used, what goals it optimizes for. Explainability is making the model's reasoning understandable to humans, e.g., this prediction was based on symptom A and symptom B. Both are necessary. Transparency for oversight, explainability for trust. Approaches to improving transparency. 1. Interpretable models. Using simpler algorithms, like decision trees when possible, so reasoning is inherently easier to explain. 2. Explainable AI tools, XI. Techniques that highlight which features influenced a decision, e.g. showing which areas of a medical scan led to a diagnosis. 3. Human-in-the-loop systems. Combining AI with human judgment so people can review and overrule automated output if necessary. 4. Policy and regulation. Frameworks like the EU's proposed right to explanation give citizens the right to know how decisions affecting them were made. Real-world examples. Healthcare AI. A tumor detection tool that highlights the specific area on a scan gives doctors confidence to trust, verify, or challenge the result. Finance. A credit scoring AI that can explain which factors lowered your score, e.g., short credit history, recent defaults. Helps individuals take corrective action. Law enforcement. Transparency is critical. Otherwise, predictive policing systems risk perpetuating mistrust and unfair targeting. Reflection. Think about a situation where you'd want an AI tool to explain itself. Would you require detailed mathematical steps or a simple human-level explanation? What level of transparency is necessary for everyday decisions, like shopping recommendations, versus high-stakes ones, like medical care or justice? Key takeaways. 1. Many AI systems are black boxes. We see inputs and outputs, but not the reasoning. 2. Transparency equals openness about data, goals, and processes. 3. Explainability equals making AI's reasoning understandable to humans. 4. Lack of transparency undermines accountability, trust, and fairness. 5. Solutions. Interpretable models, explainable AI tools, human-in-the-loop systems, and policy frameworks like the right to explanation.